Hello, I'm teacher Ivan from Wunna Educational Services. I welcome you to our second part of work, power and energy. We are still looking at how we handle calculations on work, energy and power. In the first part, we looked at the important formula and the important areas to read about. So if at all you missed that video, please go to our playlist, go to O-level physics calculations, scroll down, you find this video, and we learn together. In examples, our first example is telling us that a body of mass 250 grams climbs 25 steps, each of height 20 centimeters, and they want us to find or to calculate the work done. Yes, we've seen that work done is given by force times the distance, and this distance should be distance moved in the direction of force. And therefore, from force, we know that force is given by mass times the acceleration. So we have the mass, and since we are looking at height means that motion was vertical, and therefore it is vertical. Then instead of writing MA for force, we shall write mg, because the acceleration for vertical motion is acceleration due to gravity. In finding force, instead of writing MA, we shall write mg, because the motion was vertical. That is from the word height. Hope we are together. Times the distance d. Remember when we were looking at the formula for work done, there is an important note where we saw that in case of staircases, the total distance is given as the number of steps times the height for each step. So let us replace this is mg times nh for distance, where n is the number of steps and h is the height for each step. So that gives us mg nh. So we substitute, that is 250, but it is in grams. So we must express it as kilograms. We shall divide by 1,000 times the acceleration due to gravity, which is 10, times the number of steps, which is 25, times the height for each step, which is 20, but it is in centimeters. We must express it in meters. So we shall divide by 100. And once you compute this, we shall end up with our work done in joules or Newton meter. So that has been our first example. The second example is telling us that an object of mass 500 grams moves through a distance of 40 centimeters vertically. So they want us to find the work done. The moment we see a vertical motion where we have force, we shall use mg instead of ma, because for vertical motion a equals to g. And therefore, for this particular number, work done is given as force times distance. But where we have force, we shall write mg, because force is given as mass times acceleration. But since the motion is vertical, the acceleration is acceleration due to gravity. So that gives us the formula for work done as mgd. Therefore, we just substitute. M is 500 over 1,000. That is changing the 500 grams to kilograms. Times G is 10, and then D is the distance, which is 40, but the 40 is in centimeters, so we change to meters. That is simply by dividing through by 100. So we can reduce 5 times 4 gives us 20. 20 divided by 10 gives us 2. So the work done will be to either Newton meter or 2 joules. But it's better to write the SI unit. So you should use joules. That is our second example. Let us look at the third example. In our third example, we are told that an object of mass 750 grams moves with a speed of 30 meters per second. And therefore, they want us to find the kinetic energy of the body. But don't forget that kinetic energy is given by a half mv squared, where m is the mass and v is the velocity or speed. Therefore, it is just a matter of substituting in. That is a half times, where we have mass, we shall replace it with 750, but this is in grams, so we divide by 1,000 to change it to kilograms, times the speed squared, that is 30 squared. So that gives us a half times, we can reduce this and that is 0.75 when we divide, times 900. So you simplify that with the help of a calculator and get energy. Still, energy is measured in joules, just like a work done. Then let us look at the last example in this lesson, that is example 4, whereby we are told that an object of volume 100 cubic centimeter and density of 80 grams per cubic centimeter moves with a speed of 10 meters per second. And therefore, they want us to calculate the kinetic energy of that object. Now, we've seen that kinetic energy is given by a half mv squared, where m is mass. But in our question, we don't have mass, but we instead have volume and density. We must find a connection between these two and mass. Don't forget that from density equaling to mass over volume, we can make mass the subject, where mass equals to density times volume. And therefore, instead of mass, we shall say density times volume. So that gives us kinetic energy as a half times the mass, which is density times volume, then times v squared. Don't confuse this v. This v is velocity, this one is for volume. So we substitute. This is a half times the density of 8 times the volume of 100. However, this one is in grams per cubic centimeter, this one is in centimeter cubed, meaning that our mass from those units will be in grams. Therefore, we divide by 1,000 to change it to kilograms. Then times the square of the speed, which is 10 squared. So we can manipulate this. This is times 800 over 1,000 times 100. We reduce the number of zeros. A half of 80 is 40. So that gives us the kinetic energy as 40 joules. So that is how we shall get the kinetic energy of the body. Otherwise, we are still looking at the calculations of work, energy, and power. We are going for our third lesson. So please, don't forget to subscribe and hit the bell such that you get notified whenever we have a lesson, so that we may learn and enjoy learning together. Otherwise, I'm Teacher Ivan from Wuuna Educational Services. I welcome you to all our e-learning platforms. We are on Facebook, we are on TikTok, we are on YouTube. Just search for Wuuna Educational Services, Wuuna e-learning platform, Wuuna Kids platform, Teacher Ivan's online class. You'll always find us. Like, follow, and subscribe to our channels. Otherwise, meet you in the third lesson.